Good afternoon. In today's session, we will solve some numericals, some multiple choice questions on the three-phase induction motor. Rishikesh, mute yourself. Okay. Uh, so, already all the equations, all the theoretical part, all the numericals, equations already we have seen. So, today we will solve some MCQs. So, there is a question like a three-phase 440 volt 50 hertz induction motor has a 4% slip. The frequency of rotor current will be. So we are denoting frequency by letter F. We are supposed to derive the frequency of rotor. You guys will get confused if there is question like this because you will see here there is already frequency is given. But this frequency is the maximum frequency of the induction motor, and you are supposed to calculate the frequency of rotor. So that is nothing but Fr, and we are having the formula Fr equal to slip into frequency of induction motor. So you can take here, they have given the slip value 4%. So 4%, 4 by 100, you will get 0.04 into 50. If you solve this, you will get here 2 hertz. 5 into 4, 20. So you will get 2.00. So you will get here 2 hertz. Like that. If we are having the question, in which of the following region induction motor operation is stable? So we have seen the principal operation of induction motor, how it is working in the high slope region, low slip region. So here we are supposed to tell induction motor operation will be stable. So if the value of slip is less, at that time you will get the value of induction motor speed will be stable. So we can say for a low slip region, when you will get the value of slip is very small, because for low slip region the value of slip will be small. So therefore you will get the term S into reactance. We can neglect that and you can take R2 as a constant because we are having the formula. How we are having the formula? Torque equal to S into K into R2 upon R2 square plus SX2 square. So we have seen there, we are supposed to find here how we will get the induction motor stable. So if we are saying here the value of S slip is small, at that time you can neglect S into reactance and we can take resistance as a constant, so you will directly get torque is directly proportional to S. So we can see here we will get the graph will be in the straight line nature. So we can say that region as a stable region. Now there is a question on speed, that is nothing but synchronous and the rotor speed. Rotor speed we are denoting by capital N, or you can take as a capital N suffix R. Synchronous speed we are denoting by capital N suffix S. So there is a question like a 4-pole 50 hertz, number of pole P equal to 4. Frequency of induction motor, this is F, 50 hertz. A 4-pole 50 hertz induction motor is running at 1300 RPM. This is nothing but, this is the speed of rotor. So you can take that as an NR or capital N directly. Find the stator magnetic field with respect to the rotor. So here we are supposed to find the speed of stator magnetic field. So that is nothing but Ns minus N, or we can say a slip speed. Sometime there is a question you are supposed to find the slip speed. Sometime they will interchange the language. They will make that complex and they will write like find the speed of the stator magnetic field. At that time you are supposed to understand. This is nothing but Ns minus N, or we are saying that as a slip speed. So here you are supposed to find ns minus
Shiva,
n.
12.
Piyush, please mute yourself. If you have faced any issue in the numericals, if you are not getting any point at that time, you can unmute and you can ask. Otherwise, please don't disturb the class. So here we are solving numericals. Here we are supposed to find the speed of stator magnetic field. So here they have given us the value of pole. They have given us frequency. So you can calculate synchronous speed. So you can calculate here synchronous speed. How? We are having the formula. Ns equal to 120 F upon P. So if you solve, you can write here F as a 50 P as a 4 pole. They have given here. So 120 F upon P. If you solve, you will get 1500. Now, you are supposed to find here the speed of the stator magnetic field. That is nothing but ns minus n. Ns you have solved, n they have given. So directly 1500 minus 1300, you will get 200 RPM. If you see our first question, here they have given here the frequency, they have given here the voltage, but if you see there is no need of these things, so don't get confused. If whatever the terms they have given, you are supposed to find only the question what they have supposed to give you. So if there is, you are supposed to find the frequency operator, what you terms will require, only you will require slip and you will require f. Slip they have given here, so directly we can take. Now we will start the fourth question. So here, if we see, if the applied rated voltage per phase is reduced, so now again you will require the our torque equations. What is our torque equations? Tau equal to S into K into E2 square, R2 upon R2 square plus S X2 square. So here they have given, if we are reducing the applied rated voltage, it means what? E. You can take E or you can consider that as a V. Piyush, please mute yourself. So here they are saying, if the applied rated voltage per phase is reduced to 1/2. 1/2 means if you are taking that as a V, you are reducing half. So V by 2. If you are taking E, you can take E by 2. So if we are reducing the voltage to 1/2, then starting torque of a squirrel gauge, if there is a squirrel gauge or there is a slip ring, we are having the same equations. So here you are supposed to find the value of starting torque of squirrel gauge induction motor becomes. We are having the formula, but here only we are supposed to find how the value of applied voltage will be in relation with the torque. So we are having the equations, torque is directly proportional with the voltage square. So here we are making its value half. So V by 2 का square हो जाएगा. V is constant term, you can take that because you are supposed to find the value of rotor, value of torque with the voltage. How the relation between torque and voltage. So you can keep torque as it is, V as it is. Now 1 by 2 ka square, you can take 1 by 4. So you will get the torque value that will become 1 by 4 of the initial value. So you can say here, sometime you will get confused. Sometime if you are taking here, it is twice. You will write here 4 times, but it is not a 4 times because we are making it half. We are making it half. So half ka square 1 by 4. So you will get that value of torque will become 1 by 4 of the initial one. Now we can solve another. So here, now question is an 8 pole P equal to 8. 3-phase induction motor is supplied from 50 Hz, F equal to 50 Hz on full load NL. on full load. The frequency of induced EMF in rotor is, so they have given here the frequency of, on the full load, the frequency of induced EMF. So you can take that as FR, because they have given here the frequency of induced EMF, and this is the frequency of induction motor. So you can take FR equal to 2 and F equal to we are taking here 50 because they have given. Then the full load slip and corresponding speed will be, you are supposed to find. Full load slip means what? You are supposed to find here slip. So we are having the formula. Slip equal to percentage slip. So firstly we are supposed to find slip. How will you find? We are having the formula FR equal to S into F. We are having both frequency. You can directly take S equal to FR by F. FR we are having 2 hertz. F we are having 50 hertz. 2 by 50. If you solve, you will get 0.04. Now you are supposed to find the percentage slip. So 0.04 into 100, you will get here 4%. So here now we are supposed to find the full load slip. We have solved corresponding speed. So corresponding speed is nothing but you are supposed to find here speed. How will you solve? We are having the formula. How? We are having S equal to ns minus n upon ns. If you moderate that equations, you can write n equal to ns1 minus s. So firstly, we can find the synchronous speed because they have not given. You are supposed to find n. We are having the value of slip, but we don't have value of the synchronous speed. So how we can solve? We are having the synchronous speed and s equal to 120 f upon t. So we can write 120 into frequency they have given 50 hertz. P number of pole 8. If you solve, you will get 750 rpm. Now you are supposed to find the rotor speed. So rotor speed is nothing but n equal to ns1 minus s. So n is 750. 1 minus 0.04. If you solve, so if you solve, you will get 750 into 1 minus 0.04. You will get that value as a 720 rpm. You can write that answer in the rpm or the rps. Now, the same equations you will be needed here. There is a question like a 4-pole 3-phase 50 hertz induction motor runs at a speed of 1470. So that is nothing but the capital F. 50 hertz frequency F. 4-pole number of pole P equal to 4. Then the frequency of induced EMF in the rotor under these conditions. They have given here 4 options. You are supposed to find the correct one. How will you find? You are having the formula for slip and S minus N upon Ns. We don't have the synchronous speed, but we can calculate. How? Because we are having the formula 120 F upon P. So 120, firstly you are supposed to write here. If there is a question in theoretical, if you are supposed to write the answer in the MCQs at that time, you can directly tick which one is the correct. But if you are supposed to faces the theoretical examinations, you are supposed to write up the paper. At that time, you are supposed to write the given number of pole P equal to 4, F equal to 50 hertz, capital N equal to 1470 RPM, F equal to question mark. At that time, how will you get? We are having the FR equal to S into F, but you can write but S equal to NS minus N upon NS. But for that, you will again needed the NS. So, but we have NS equal to 120 F upon P. So, firstly, we will solve NS 120, frequency 50 upon number of pole 4. If you solve, you will get 14415. This one. So here If you solve, you will get here 120 into 50 upon 4, that is nothing but 1500 RPM. Now, we are supposed to find the slip. How will you find? We have just solved synchronous speed, that is the 1500, and we are having the rotor speed, that is the 1470. So if you write here 1500 minus 1470 upon ns, that is the 1500. If you solve, you will get 0.02. Now we are having the equation for the rotor frequency, that is nothing but Fr equal to S into F. So you can solve, you can write the value for slip, you can write the value for frequency. If you write, you will get here 0.02 into 50, you will get here 1 hertz. This question I think we have not done. So here, an 8-pole 3-phase induction motor is supplied from 50 hertz AC supply on full load. The frequency of induced EMF in the rotor is 2 hertz. We have solved. Sorry, we have solved that. So here, the 7th one. The rotor current in a 3-phase induction motor is. So we have seen the equations. How will you get? We have seen, we will get here rotor current, that is nothing but at the normal speed, if we are taking, there is a synchronization. We can take Sx2, slip into reactance is very small and we can neglect that. So here we can directly take E2 and R2 will have a constant value. So we can take that as a fixed. So directly you can say the value of rotor current is directly proportional with the slip. You will get I will directly proportional with the S. Now, we are supposed to find if a slip of 3-phase induction motor increases. It means what? If we are increasing S, the power factor of the circuit will be. So power factor we are denoting by cos phi. So we are having the formula P equal to square root of 3 VL IL cos phi. So here we are supposed to find if the slip of 3-phase induction motor increases. So we can say rotor reactance is a function of frequency. And if we are increasing in the slip at that time, it will causes the increase in the rotor frequency, because we are having the formula Fr equal to S into F. S का वैल्यू बढ़ रहा है तो क्या हो जाएगा? F इक्वल टू एस इंटू एफ आर इक्वल टू एस इंटू एफ है. हम यस का वैल्यू बढ़ा रहे हैं तो क्या होगा? एफ आर का वैल्यू बढ़ जाएगा. सो वी कैन से as the rotor reactance is a function of rotor frequency, and if we are increasing the slip, it will causes the increase in the rotor frequency. So you will get increment in the Fr, and hence there is an increment in a total reactance. So we can say that will increase the total impedance, because here we are increasing the reactance. And what is the formula for the impedance? Z2 equal to R2 plus JX2. So if we are increasing the reactance, impedance will get increased. So we can say as we are putting the rotor resistance as a fixed constant, rotor power factor will get decreased. Now there is a question like, if supply voltage of 3-phase induction motor is increased, that time there was decreased. How? 1 by 2. तो हमें आंसर क्या मिला था कि इट विल डिक्रीज 1 by 4. तो यहाँ पे क्या हो जाएगा? What they have given, if the supply voltage of 3-phase induction motor is increased 2 times, torque will be increased 4 times. Absolutely, because we are having the formula T is directly proportional to the V square, and we are having the value, we are increasing value twice. So 2 into V2 square. So V2 as it is, 2 का square 4. So you can say here the torque value will increase 4. You are supposed to face the unit test 4 on that unit. There will be also the numericals, and in the same manner there will be the questions, some on the numericals, there are some questions are on the theoretical construction part of the 3-phase induction motor, the differences between slip ring and the squirrel cage. If there is a higher starting torque at that time, which induction motor we can prefer? Like we can prefer that time slip ring or the wound induction motor. So like that. Now we can solve the next numerical here. there is a question like for a sleep of 0.05, so this is nothing but the sleep S. Find the ratio of rotor speed. They have suppose we are supposed to find rotor speed for two induction motor because they have given here. Find the ratio of rotor speed with the motor which will operating with 4 pole and the 6 pole respectively. So here we are supposed to find the rotor speed for which will have the 4 pole and which will have the 6 pole. So firstly we will solve the rotor speed with the 6 pole and slip we are taking both time 0.05. So we are having the formula. What is the formula we are having? We are having n equal to 1 minus s, 1 minus s into, we are supposed to take here into capital N because they have given here. For a slip of 0.05, find the ratio of rotor. So if we are taking here 1 minus, because we are having s equal to ns minus n upon ns. So directly what we can write here? We can write here, we are having s equal to ns minus nr ns. We are having that equation divided by ns. So we can rewrite that equation like that. You can see here. You can write n equal to ns into 1 minus s. This equation will be needed here. This. So here. So here, if we are solving 1 minus s, s is nothing but 0.05. And if we are taking the speed 1500 rpm, at that time you will get that speed as 1425. If you solve, you will get that answer. If we solve for the 6 pole, you are supposed to consider here the 6 pole. And how will you get that 1500, the value? Can anyone tell me how we will get here ns equal to 1500? Because if you see the question, they have not given the value of ns, but I have taken 1500. Rishikesh, can you answer the question? It is very simple. It is very simple. Because we have seen the 9 MCQs here. In that only you will get the answer. Here you are supposed to find how we are taking the synchronous speed as a 1500. Because we are having the formula FR. I will show you. We are having the formula FR equal to S into F. See this. We are having the formula FR equal to S into F. So in that way, you can put the value of slip, you can put the value of frequency. So you will get the value of FR. And after that, we are having the formula for synchronous speed, 120 F upon P. If you solve, you will get 120 into 50 upon 4. You will get 1500 R. 1500 rpm, because they have given here number of pole 4, and if they are not giving the frequency, you can directly take 50 hertz. I have already told that. So you will get here 1500. Now if you see here, it is changing, because here you can solve ns equal to 120 f upon p. How will you get 120 into frequency 50 hertz, number of pole 6? If you solve, you will get that value as 1000. So you can take that as directly 1000. But these are the MCQs. That's why they have not given the thoroughly. They are using the shortcuts. So you can solve here. And S for 6 pole, 120 into 50 upon 6. That will become 1000. Now you can solve nr equal to 1 minus s into ns. So if you solve that equations, you will get that speed as 950. Now you are supposed to take directly ratio nr4 upon nr6 if you are solving. You can denote by any letter. I am denoting because they have given here 4 pole, 6 pole. So nr4, nr6. If you solve, you will get 1425 upon 950. So you will get that as a, if you are minimizing, you will get that as answer 1.5. So this is the ratio. So there is no need of unit. Just wait for a minute. So if anyone is facing any issue until that question, you can ask me. Okay. So we will see the next numerical. So there is a question like, if the stator voltage of induction motor is reduced to, again it is a reduced to 50% of its rated value. So 50% you can take 50 upon 100, 0.5. So if it is rated 0.5, you are supposed to find the torque developed. It will reduced by of its load value. We are having torque is directly proportional to the V square. We can take torque equal to 0.5 V square. So 0.5 का square है 0.25 V square. So you can take, it is already we have solved. You will get that value as a 1/4. 1/4. So here that value is 1/4 of its initial value. So we can take, it will be reduced to, here you are getting the 25. So we can take that will be reduced by 75% of its load value. So you will get the answer. Because we are having torque is directly proportional to the V2 square, V square, not a V2, V square. And here we are taking that value is reduced to 50%. So 0.5 ka square 0.25. So that value is nothing but 1/4 of the initial value. So we can directly take 1/4 is nothing but 25% reduction. So we can take, it will be reduced by 75%. You will get the 75%. It is reduced by 25%. But here you will write like torque will be developed and it will be reduced by 75% of its full load value. Of its full load. That's why we are writing here instead of 25, 75. क्योंकि हमें जो value मिल रहा है वो क्या मिल रहा है 0.25 V square. So we can take that as 1/4. So you can take that value will get reduced by 75% of its load value. Now we will see that this numerical and then we will conclude our session. So a 3-phase 50 Hz 8 pole squirrel cage induction motor run at a speed. We are having the values of frequency and pole. You can calculate directly synchronous speed and S equal to 120 F upon P. And what we have seen? We have seen capital N always will be less than synchronous speed. So जितना speed मिलेगा उससे कम रहेगा. So directly you can calculate that. You will get that as a 750. So you can say that value will always less than. If there is a less than or equal to, at that time answer was wrong. Because we are supposed to find the speed of induction motor, not a synchronous speed. And synchronous speed is a 750. So we can say the 3-phase induction motor will work at a speed where you will get the value of rotor speed will be less than its synchronous speed. So you can take always that as a less than 750 RPM if you will get that value. So we can say induction motor speed or rotor speed, capital N, is always less than synchronous speed. We will see the remaining numericals in the next class, in the tomorrow's session. Now I'm taking your attendance. If you guys are not facing any issue, you can leave now. Thank you.